All right, so this is a follow-up to the last couple of recordings about ions and isotopes. So if you haven't got the definitions of these things down yet, go back and watch those. But this is just a focus on making sure that if you're given problems and you're asked about how many electrons there are, how many neutrons there are, for any of these types of things, you'll know how to attack those. So by the end of this, you should be able to tell me how many protons, electrons, and neutrons exist in the elements below using nothing more than the symbols you have here and maybe a periodic table. So just a quick review of the last couple of recordings. So isotopes have a different number of protons, electrons, or neutrons. Hopefully you said neutrons, that's the isotopes. They have different neutrons. Now because their neutrons change, they might have more or less of them. What other value might change in addition to that? So like, what are neutrons of impact? Again, hopefully you are saying atomic mass. All right, because that atomic mass is your protons plus your neutrons. So if the number of neutrons changes, so does the atomic mass. All right. So ions, on the other hand, have a different number of electrons. All right. So here we're going to have either more or fewer electrons than our standard neutral atoms. And what does that do? How does that affect the atom? All right. These atoms have a charge. They're not neutral. Might be positive, might be negative, and that depends on whether or not we lose or gain electrons. Okay? All right, so this is something we talked about several lessons ago. All right, but how, if we're just dealing with a plain old neutral atom, just the standard version that shows up on the periodic table, how do you figure out how many protons you have? All right, that is going to come from your atomic number. Right? That is one thing that is always, always, always true. Atomic number is your number of protons. That never changes. All right, those two things are fixed. All right, so the atomic number of carbon is 6 and only 6 and always 6. All right. The number of electrons for a neutral atom, all right, by definition, neutral means there's no charge, so you get that from the number of protons. Once you know how many protons you have, you know how many electrons you have to have because it's neutral. And then you get the number of neutrons from your atomic mass. Now there is a calculation there, all right, because let's refresh our memories. The atomic mass is a combination or the addition of two things. So that's going to be your protons plus neutrons. So if we need to figure out neutrons, we're going to take that atomic mass and we are going to subtract your protons. All right? This is key and important to figuring out how to deal with isotopes and ions based on their slight differences. All right? So for isotopes, isotopes have a different neutron number. This means that either you have to be given the neutrons or you have to be given its mass, all right? So for an isotope, you get the atomic mass number from your problem, from the example, something like that. Oftentimes it's written like, you know, carbon dash 14. And that 14, that's your atomic mass. All right, so just remember if you see, you know, carbon 14 written down or calcium 42, you see that number written in there, remember that, oh yeah, I don't use the periodic table this time for the atomic mass, I'm going to use the number that's given to me. Okay? So that's where these come in handy. All right, so you can see some of these have the mass number written on them, or they have a spot for you to write the mass number in because they're going to be isotopes. So the first 3 of these were done in the recording yesterday, so let's do a different one that hasn't been done yet. So, for example, cesium-140. All right, so since it has that 140 on there, that tells me that my mass of cesium is going to be 140. All right, now I still need the periodic table because I don't know the atomic number of cesium off the top of my head. All right, so if you don't have a periodic table open already, pause the video, go get one open, look up cesium. All right, so if you look up cesium, its atomic number is 55, and we can tell that we're dealing with definitely an isotope of cesium because on the periodic table, our mass is 133, or 132.9, but since we can't have partial neutrons, we round that. All right. But this one, I am being told by my problem that I need to use the 140 mass. All right, so now let's fill in some of the other things. Let's see, off the periodic table, I can see that my symbol is CS. All right, my protons are going to be the atomic number, that's 55. All right, I'm dealing with isotopes, not ions. So isotopes are neutral, so that means my electrons are also going to match my protons, so they have to have equal positive and negative. And my neutrons, I do what I've always done in the past, that's 140 minus 55. I just need to use that 140 number. 140 minus 55 is 85. Oops, my little bar is in the way here, so I'm just going to write that up above. 85. All right, so just to do one more, let's see. This is a little funky here, number 12. All right, so I've got this dash, so I mean I know my atomic mass is going to be 18, but I don't know if this is going to be the most common isotope. So, and I actually don't see anything on the periodic table that has a mass of 18, so I don't know which one I'm dealing with. So let's look at what else I have. Let's see, I've got my electron number. How can I use that to figure out some of these other numbers? Well, I know isotopes are neutral, so if my electron number is 8, and I have 8 negative charges, I'm going to have 8 positive charges, so 8 protons. And then if I figured out my protons are 8, then that means my atomic number has to be 8, which means on the periodic table, if I go find the element that has an atomic number of 8, I am dealing with oxygen. So this is oxygen 18. All right, so now my last step is to figure out my neutrons, which is going to be 18 minus 8, or 10. Okay? So feel free to try a few more of these. Again, if this isn't making sense, this is going to show up on your test. Come get help. All right, so now ions. All right, so we still have our same set of tools to work with, but we have to adapt them for the fact that we know that there is going to be a charge. All right, so that charge comes from how many positive charges I have and how many negative charges I have, and you just add them together. So add the positive protons with the negative electrons, and whatever those add up to be, either positive 1 or negative 2 or whatever, that's your charge. All right? Now we get our proton number, still, always, 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 from our atomic number. All right? The electrons, if you aren't given them, say you're given a charge, all right, it's going to be the number that makes the charge true. All right, and we'll do some examples to kind of help you figure that out. But your number of electrons is going to be however many electrons gives you the charge of your ion. All right, so say you have 5 protons, but the charge is going to be -1. You're going to need 6 electrons to get -1. All right, because +5 and -6 gives you -1. And then the number of neutrons, all right, this is going to be our standard atomic mass minus protons. Now for these, you can use the periodic table mass, all right? I'm not going to combine isotopes and ions at the same time. So just go to your periodic table, round that number to the nearest whole number, and then subtract away your protons. So, some example type problems. And honestly, normally with an ion calculation, you're just going to be asked about the electrons, right? Because we want to know how is this charge happening? What's going on? So iodine forms an ion with a -1 charge. How many electrons? Right? I always want you to sit there and think about this from the neutral state, and then it's forming this ion. So let's look up iodine. Iodine's atomic number is 53. So that means we have 53 protons when it's neutral, and 53 electrons when it's neutral. All right, or when it's neutral, we have plus 53 and -53. All right. When this becomes the ion, so we want to make sure it's -1. All right, I'm still going to have the plus 53 protons. That's never going to change. But what am I going to add to positive 53 so that I get -1? All right, do I need another electron or do I need to remove an electron? If you're not sure, try both. All right, because 53 minus 52 is +1, but 53 minus 54 is -1. So there are 54 electrons. All right, and then e to the negative sign is a way of writing out electrons. So let's do one more of those. We'll do a positive version. So calcium forms an ion with a +2 charge. How many electrons? Again, you got to go to your periodic table, figure out what you're starting from. All right, so when calcium's neutral, we have atomic number is 20. All right, so we'll have 20 protons and 20 electrons, or +20 and -20. And then when I become my ion, I'm going to be +2. I still have my 20 protons, because calcium has 20 protons, period. If I change the number of protons, it becomes not calcium. So now I need to figure out, so what am I going to do with my electrons? What can I add to +20 to end up being +2? All right, so really do I add 2 electrons or do I remove 2 electrons? Again, if you're not sure, try both. All right, so if I make it if I make it 18 electrons, so it's 20 minus 18, that's +2. That sounds like it works, but just to make sure, I'm going to also try -22. So if I do 20 and -22, I get -2. So yeah, that's not the right sign. So I need 18 electrons to get that +2. All right. So if you're ever not sure, try both. One of them will work. And then I want to go over one other example. All right, so we've got this here. An ion with an atomic number of, what does that say, 13, has a +3 charge. How many electrons does it have? So technically from here, I don't need to go figure out what element this is, but just so you know, because it gives you your atomic number, you can go to the periodic table, find 13, and know you have aluminum. All right? So if you're ever asked to determine what the element is and you're given an atomic number, just go hunt down the element with that atomic number, and that's what you have. So if I have an atomic number of 13 and it has a +3 charge, so when I'm neutral, I have 13 protons and 13 electrons, or plus 13 and negative 13. Now, to become an ion with a positive 3 charge, that means I need to still have my positive 13 protons, but how many electrons should I have? Do I want to lose 3 of them and make it 10? Or do I want to gain 3 and make it 16? All right, which negative value added to 13 is going to give me positive 3? Hopefully you are saying 10. All right, so that means there are 10 electrons in this case. Again, if this is not making sense, come get help, because you will be seeing this on your unit test.